Okay, we haven't covered these yet with this topic, substitution. We did do it with graphing. Remember when they were parallel lines? We know that they're going to have no point of intersection, and so they must have no solution. Um, if they are the exact same equation, then it's going to be infinite solutions because it's going to be the same line and they're going to be laying on top of each other and they're going to have an infinite number of points of contact. So essentially any set of points in x and y, or set of coordinates in x and y that solves one will obviously solve the other because it's the same equation, even if it's written differently. Okay, well, what's going on here? What's going on here is that we're going to substitute in, and if we see the, like if we substitute one variable and the other variable also disappears, then that's going to be one of these two special situations, infinitely many solutions or no solution. Okay, if we substitute in and the other variable that we're trying to have remaining doesn't disappear, then it's just going to be the normal one solution type situation, just regular lines that cross in one place. Okay, but if the other variable goes away, then we're going to either get one of two situations. So how do we tell the difference? Well, as you'll see, the reason that we can tell the difference is we're either going to get a true statement, always true, something like 20 equals 20, which is, when is that true? That's always true. That means infinitely many solutions. Or we're going to get some false statement like 20 equals 10. And when is that true? That's never true. Under no circumstances is that true. There will be no solution. So let's see what we get. Okay. We need to isolate a variable. So I'm going to zoom in on this one. And I'm going to do a quick little screen grab of this one. And that way I'll be able to solve for x, because what's happening now, well, I remember before when I added x to both sides and then I could subtract away 6y to move it over. I'm going to actually do something slightly different, which is subtract the 10 from both sides. So you get negative x equals 6y minus 10. And then, well, what's in front of x? It's negative 1. So I'm going to do negative x divided by negative 1 equals 6y minus 10, all divided by negative 1, essentially changing the sign of this to be x equals negative 6y plus 10. Okay? Like that. Now, what do I do with that? Well, I take the other equation, and the other equation is, let's do a screen grab of it. Actually, oops. Let's do a screen grab of it right here. Stick right there. What do we do with that? We're going to say 5 equals 1/2 of whatever x is equal to plus 3y. What is x equal to? X is equal to negative 6y plus 10. Okay, so we're going to have to take half of that amount is really what we're doing here. So we say, oops, 5 is equal to, what's 1/2 of negative 6y? Well, that's negative 3y. And what's half of 10? Well, that's 5 plus 3y. And when we combine like terms, what are the like terms? The like terms here are the negative 3y and the positive 3y. What do we get when we combine them? We get 0. That's the variable going away, the second one going away, like I was talking about. So we just are left with 5 equals 5. And when is that true? When is 5 equals 5 true? That's always true under all circumstances. No matter what point we choose, we're going to get a true statement. And so how do we describe this? Let's do this. Let's just do a screen grab, because I'm really enjoying this tool that I just kind of decided I'm going to start using. That answer is infinitely many solutions, because we get an always true statement of 5 equals 5. Kind of neat, right? Okay. Oops. Okay, let's do the same thing here. Oh, do you want to see something neat? Okay. Excuse me. Let's see. First of all, I'm just going to point something out. Notice how this says 12x plus 11y. And this also says 12x plus 11y. Their order is switched. Okay, but that's fine. They both have that amount. So how can it, on one equation, equal 14, and that exact same amount, the exact same number of y's and the exact same number of x's over here equals 17? Suspicious. No, don't like it. That's going to be a no solution situation. I'm predicting it based on the fact that the same amount twice is ending up being equal to different numbers. That's not what we should get. I want to show you something though, something that's neat, and for those of you that are sophisticated, you'll really enjoy this. Okay, check it out. It seems really kind of creepy to try and isolate the variable when there's this really weird number of them. Okay, let me just pull this over here, and let's see if I can shrink these down. Oh, yay, I can. Neat. Okay. So check it out. I don't actually have to isolate it down to a single y. See how this says, oops, see how this says 11y there? Watch what I'm going to do. This is great. I'm going to subtract 12x away. Minus 12x, minus 12x, and I get 17 minus 12x is equal to 11y. Okay? Well, why do I care? Because see over on this equation where I have 11y, I know what 11y is equal to. 11y is equal to 17 minus 12x. So I don't have to get it down to a single y. I can just say we have that same number twice, so I can just substitute in. I can say 12x plus parentheses. I'm going to replace 11y with what I know 11y is equal to. And what is 11y equal to? Over here, 11y is equal to this amount. So that's going to go right in there where 11y used to be. Yep. Hopefully you're making sense of that. So where I saw 11y, I'm going to now write 17 minus 12x. Okay, cool. Now let's simplify this. Well, this says right here, this says positive 1, or it's positive rather, right? Just adding that amount. So we're not distributing a negative through anything. So we just basically have 12x plus 17 minus 12x equals 14. And when we combine like terms, that and that are like terms, they're both x terms. What happens? What's 12x and negative 12x? Boom, they go away. Wow, they go away. And you are just left with a false statement of 17 equals 14. Not true. So another special situation, because when you tried to eliminate one variable, you had the other variable disappear out too. And then so you examine the result, and if the result is false, 17 equals 14 is false, then what we say about this is that this is a no solution situation. So I'm going to grab that. No solution. Stick it right down there. No solution for that one. Okay. All right. We're on our way. Now, what can we do here? Well, I'm going to grab these two equations. I'm going to bring this over here. And I'm going to bring this over here. Okay. And let's do this. We need to isolate one of the variables. I'm going to do the similar thing to what I did before. But actually, no. You know what? I'm going to do something different. I'm going to double both sides. Okay? And I'm going to say, sorry. I'm going to say 2 times 1.5x plus 2y equals 2 times 11, what was there, okay? And now we need to distribute through that times that, that times that. What do we got? 2 times 1.5, well, 2 times 1.5, hopefully you can see, is 3x. And 2 times 2y is 4x equals 22. Okay. Why did I do that? Because I'm going to do my same trick. I'm going to do my same trick. See how once I did that, I have 3x here and 3x here. So what I'm going to do then is I'm going to just say minus 4x, and I get, I'm sorry, that should have been a y. My mistake, forgive me. Actually, leave it there and erase it. I should have written a y there, not an x. That was my mistake. This should be a y. Thank you for your patience. I make mistakes too. Okay. So I'm going to subtract 4y from both sides, and I get 3x equals 22 minus 4y. And notice that this 3x, and there's a 3x there, so where I see it over there, I can actually just substitute it with what it's equal to. Okay? So, zoom in here a little bit. See if I can grab that and move it over. I know that 3x is equal to it's actually equal to 22 minus 4y. Plus 6y equals 22. And now, if I combine the like terms, negative 4y plus 6y equals 22. It seems like we're going to get something funny, but we're not. This is not funny. What I mean is, it's not an unusual special case, because watch, what is negative 4y plus 6y? It is positive 2y equals 22. And when you subtract 22, notice that when we substituted in, the other variable did not disappear. We still have a y term here. And if we still have a y term, then we are not dealing with a special case. Special cases happen when, as you substitute one variable's equivalent expression, the other one goes away. So we say 2y divided by 2 equals 0 divided by 2, and we get y equals 0. That's a legitimate value for y to be. Y equals 0. Okay? So how do we find out what the other value is? Well, we can take one of the equations, and let me grab one. Sorry about that. Let's grab that and drop in where we see y. Let's drop in 0. So we get 3x plus 6 parentheses 0 equals 22. And that means that 3x equals 22. And dividing by 3, we get x is equal to 7 and 1/3. So we have a set of coordinates that is 7 and 1/3, comma, 0. Okay, that seems legit. Let's take the other equation and plug it in and see what we get. Okay. Well, I can do this. I'm going to skip this part for your sake so it doesn't burn you out on this, and I'm just going to say this. When we did this, watch, let me just review this and you'll see what's going on. I'm going to use my red dot here, okay? I changed this equation just by multiplying everything by 2. I just rewrote the equation a little bit, still equivalent. and so that it said 3x. And then I isolated that 3x. And on the other equation, where I saw 3x up here, I put what it was equal to. And you can see that the other variable, we were getting rid of x here, right? We were substituting x with an equivalent value in y in order to be able to get down to a single variable. Did the second variable y go away? No, it didn't. It didn't actually go away. The constant went away, but that's not the same as the variable going away. The variable did not go away. We were still able to solve for a value of the variable. What am I getting at? What I'm getting at is that this is not a special case. This is not a special case because the second variable didn't disappear in the process of you substituting one variable. So what does that mean? Well, what it means, what they're really asking us to do is simply identify how many solutions are there. Tell whether the system has one solution, infinitely many solutions, or no solutions. And we already can tell that because it's not a special case, it's going to have one solution. And that's what I'm going to do. I'm just going to drop it down there and I'm going to say, it's got one solution. And, oops, I'm going to save you the trouble of having to do that proof there with the complicated fractional amount, because I can do it, but it'll take a lot of time. And the real value here is in seeing that, unlike these first two, where the variable dropped out, let's zoom in and you can see it one more time. Okay, here we isolated x, oops, we isolated x, and when we substituted that value in for x, that other variable y canceled out. There were two exactly opposite amounts, and it canceled out, leaving you with a number statement, 5 equals 5 in this case. And over here, when we isolated, we just isolated 11y, and where we had 11y in this equation, we substituted what 11y is equal to. 11y is equal to this. So we substitute that amount in. And as you can see here again, exactly opposite amounts. We tried to replace y with just x's, so we had just x's left. And the x's went away too. Special case, when the second variable goes away as well. But in this case, you got a false statement. 17 does not equal 14. We got a false statement, which means there's no solution. Okay? Versus this third situation where when we substituted it in, we isolated 3x, and when we substituted or replaced 3x with what it was equivalent to, 22 minus 4y, we didn't end up getting the other variable y disappearing. It didn't also disappear. Not a special case. So that means it's just a regular type with one solution. And so that's what we have for answers. We've got, first one is infinitely many. Second one is no solution. Third one is just one solution.